Well, hi, good morning. Thanks for joining me here in my shop. So I think what I want to focus on today is something I haven't even mentioned about this receiver at all. And that's the bit of distortion that I can hear in the audio. Now, my assumption was, as things went on and things got improved and this and that, the distortion would go away. But last time we played this radio and I listened to it, I could hear what I think is distortion. So my first objective today is to find out, is it really distorted? And what I intend on doing right off the bat is connect a much more powerful antenna to the radio, tune in an AM station, and listen again and see if I really hear that distortion. These old radios, to listen to broadcast band programs, a regular AM radio, would commonly have a loop antenna connected to them. And I have a homebrew loop antenna here, which I'm just going to flip my camera around and take a look at it. And this would be, similar to what somebody might have in their house for a radio like this. So this is a really, really simple idea with an antenna like this. There's actually two loops in it. The first loop has looks like 5 turns of wire here, and then the loop is completed with a capacitor, a variable capacitor, which you can see, here. And that's it. That's just it. It's not hooked up to anything else. It's just sitting on these poles. 5 loops of wire with a capacitor connected across them. Now, because of the size of the wire, the size of the loop, and all that kind of stuff, the capacitor and the loop will resonate in the AM band. So without anything going on, right now, in fact, there are AM radio signals striking this antenna, or maybe not striking the antenna, but involved with the antenna. And right now, this capacitor is set somewhere, and this coil and capacitor are resonant at some frequency. Let's take a wild guess. 680. Oh, there happens to be a radio station at 680. So this coil, if this is true and it's tuned to 680, this coil is humming with 680 signal right now. Okay, there's reasons for that. But of course, it's over here, it's not in my radio. So there's another wire. Here's the other wire. A single turn, a single wire goes around the loop once, comes down here and attaches to the outgoing cable. Here's the outgoing cable. It's going to go over to the radio. So most loop antennas, or all loop antennas, are built on this kind of principle of a resonant coil and a pickup turn, if you can call it that. The various combinations, the size of your coil, size of the wire, all this kind of stuff will make different combinations to make this work. I built this in college just with what I had. That's a couple broom handles, and I've dragged this antenna with me since college. If you can believe it. So the thing about this antenna too is that because it has this tuning capacitor down here, it has to be tuned all the time. It has a very, very sharp response. Just like a radio practically. So you're going to tune the radio, you got to run back and tune the antenna a little bit. So that's what's going to happen here while we're using it. But it will produce, the other thing is, because this wire is hooked up to the radio, and this wire only goes around once, it's almost like putting a short circuit on the antenna, which sounds like a crazy, crazy thing to do. With this wire connected, the single loop connected across the radio antenna inputs, it is pretty much shorted out. So all the noise, or most of the noise in that, disappears, except for what little is picked up by this short piece of wire. So it becomes very quiet, and then these ones produce a very strong signal that can get into this wire and overcome the fact that this is so low impedance. I guess that's a way of looking at it. So the result is strong signal, low noise. That's exactly what you want. Strong signal, low noise. Directional antenna, I have to steer this. So in this angle right now, it's aimed at Toronto, and that's what we're going to be listening to mostly. So that's the story on the antenna. If you've watched lots of my videos, you've seen that antenna many, many times. Okay, but if you own this radio, that's the first time you've seen this antenna. So first we'll start the radio up, we'll get it working, we'll get something tuned in, and we'll do it on the long wire antenna it's hooked up to now. Then we'll switch to the loop antenna, and we'll hear the difference, paying attention to distortion the whole time. That's my plan. Let's see how far My plans usually last about 3-4 minutes, and I have to dump them. So I think we're okay so far. Anyway, we still have the audio signal hooked up. We won't be paying attention to the AVC unless we feel the urge. Eventually, once we start hunting around for, well, what exactly is this distortion? Where's it coming from? Where's it showing up? We might be doing some scope stuff. Might be doing some signal tracer stuff. But first, the main thing is it really distorted, or is it in my imagination all this time? Okay, power on. Headphones here. Let's hear what we got. What do we got?
MVP leader Desmond Singh starts today in Oshawa before heading to Kingston, while Conservative Party leader Andrew Scheer is in Ottawa this afternoon. Liberal leader Justin Trudeau is spending the day in Quebec. The Crown says it will argue at an upcoming bail proceeding that a senior RCMP intelligence...
So this is 680. Oh, you can hear that frying sound again. You know what it sounds like? It sounds to me like the elements in a tube are vibrating. So I'm putting my hand in front of the microphone you're listening to. So it's coming right out of here. It just so happens that the microphone is positioned right above it. Okay, enough of that. Now we are running with reduced power. How much reduced power is it? It's 100 volts, which I think is probably satisfactory for this right now. So this volume control is not straightened out yet. Still not behaving quite right. So I believe I have the expander switch off. I hope I get this right now. Expander switch off. There's a ground placed through a resistor on this. Can you see that little wire there coming out of the volume control? So you can imagine now the slider inside the volume control is pointed here. And as I turn the knob, the slider is going to sweep around. Actually, it's pointed down here. I got it wrong. It's starting here. So as I turn the knob, it's going to sweep around. I don't know where it's starting. Let's just listen carefully as I turn it up, and you'll hear a couple different stages of operation, if you like. That's one. Oh, there's another one.
National Speaker Monument. And a little late with Rudy Singh, starring the Toronto-raised YouTube sensation known as Superwoman debuts on YouTube. The Indian-Canadian actress, comedian, writer is only the second woman of color to get a nightly gig on a major network in 20 years, since Cynthia Garrett hosted NBC's Later for a year in 2000. Singh says there is pressure to succeed, but she's focusing on the show and the honor of doing it. This is the Canadian Press. In sports, forward Mitch Marner is expected to join the Maple Leafs today in Newfoundland for training camp after agreeing to a new contract last night. After a long...
Yeah, it's kind of surprising the tone doesn't seem to make any difference, but I'm sure the tone has made a difference before. So it's just possible this expander switch has been in a couple different positions while I've been working on it. I don't think so. But it could have been. I may have moved it at some point. So maybe the operation has changed a bit. It's just odd that the tone, I'm sure it worked at one point. Perhaps the tone is working with the output of the 45s, and we're not listening to the output of the 45s. We're kind of listening to the input to the 45s, the 45 tubes. So that's probably what's happened here. The tone is just toning in part of the receiver we're not listening to anymore. So I'm not so sure I'm hearing distortion now when I listen to it. Oh, over here. I'm going to tune in a stronger signal here. We're still on the long wire.
we're giving away. Will it be another province again? Last month was in Winnipeg.
Yes.
Wow.
Okay, so I think I've tuned in 640, but frankly I got totally lost turning this knob, watching this thing go around. So I think I'm on 640. That's about the best signal. 640 and 590, the sports fan, are the two best signals I can get. So let's listen a bit, then I'm going to switch to the other antenna.
However, that's not the only reason you should pile up those ballots with your name on it, because at the end of it all, which is, I believe...
So I'm listening to the higher tones in his voice, the S's, they're not really there, but just the higher pitched things in his voice, and to me they sound kind of splattered out. They don't sound clear and sharp.
To see who has the most ballots in the box.
Yes.
Not a winner, because the winners will be at that point removed from this draw.
So there's definitely something going on there. Now, is it my audio system? It's very unlikely. It's almost certainly what is going on in this radio. But it's got a fairly weak signal being applied to it, and you can hear how much noise is all around it. So I'm going to switch now to the other antenna. I think there'll be a dramatic difference. We'll leave it tuned where it is right now. Now the other antenna, the loop antenna, is a 2-wire antenna. You have to hook up a ground wire. If you hook it up just the one wire on here, then that's not a loop anymore. That's just a funny bent wire as far as the radio is concerned. So we don't want that. And I need a screwdriver here.
Just go back every 24 hours, drop another ballot in the box.
Okay, so I've set the volume now. We'll see how different it is once I get this hooked up. And I have to tune the. I have to tune this guy. We might hear it right away. This is not much different than what we were just listening to. Now, when I clip this on to the chassis, I think should quiet down quite a bit. Yeah, quite a bit, eh? Say, oh man, where'd the radio station go? Remember, I'm basically hooking up a 2-foot piece of wire, looping it around from the chassis to the antenna connection, better known as a short circuit. But on that short circuit, I'm now going to try to impress the induce, maybe is the right word, induce the radio signal. I'm going to tune this guy. See what happens.
Species that are disappearing. In fact, a new species just discovered.
What?
Yeah.
Oh, okay. Where did you find it?
How's that?
Okay.
Yes.
So it's about the same volume, but there's no noise. Let's turn it up now. We'll hear what we hear. So actually, this is cranked up full here. Wow. Turn it up on my...
It was discovered in Maryland, not more than an hour from the Smithsonian Museum of Natural History. The Smithsonian Museum of Natural History. You're probably a big fan of that place.
Sure, let's go with that. I haven't been to the ROM in like years.
You haven't?
No.
This leech was unknown until recently and discovered just ways from this museum. How ironic is that? And apparently there's lots of them out there in the nearby area. The leech, of course, have a medicinal value for reconstructive.
I find it, well, I find it odd how far I can turn this knob when it's in coarse adjustment. I'm still turning it quite a few degrees, but I guess it's still gear driven.
Then your run-of-the-mill.
This has the fine tuning in the middle, and then you engage with the faster tuning.
The saliva helps control bleeding and accelerates the healing process.
Interesting.
Yep.
I wonder if you can catch a fish on it.
Oh. I'll have to look into that.
Now, distortion.
For moose hunters, this is Christmas. You know, this is that time. It's party time for moose hunters. They've been waiting all year. The annual moose hunt is now officially upon us. Opening dates may vary between wildlife management units here in Ontario, but pretty much all is happening right now. For a lot of the hunters, this is like I said, this is Mecca for hunters, right?
Hunting's a big thing in Canada, of course.
Time is here, and
not for
you're
me.
right
I'm
there,
not into it.
Oh my God, it's just
lots of
we
people.
did some research. We thought it'd be an interesting time to do a bit of research on moose, because we've been talking about moose a lot here on the program, as you know.
Yep.
Mostly because
Moose.
there's apparently a shortage of them.
Moose, yeah. Moose not too far from my house. Maybe 50 miles, 100 miles. Start coming across moose. Okay. Well, I didn't hear any distortion. Once a good antenna was put on it, we had a good signal going into it. I don't hear any distortion to concern myself with. So I think that was a false observation. Good thing I didn't talk about it before. So that's it for distortion. What are we doing next with this guy? You know, it might be fun is let's put him up on the shortwave bands and just see what happens. Even though I haven't done any alignment. Now we certainly can't do that with this loop antenna. The loop antenna is designed for broadcast band reception only, and it's tricky actually to build a loop for higher and higher frequencies, like shortwave. Can be done, but in this case we're just going to go back to the wired antenna, and I'm going to go, let's hear what it sounds like now. Where'd it go? There it is. Maybe I tuned it? Did I tune it? That station can't even pick it up on the wire. So what I'm going to do now, I'm going to leave it just like this. I'm going to run down, throw a switch, because we're actually, oh, you know what? We're not connected. Let's get connected here. Okay, but I'm still going to go throw a switch. I'll be gone for 10 seconds.
This does not cover, of course, flights over to wherever you have to fly to, and then jumper flights from there to wherever the hunt camp is, and all that stuff. This would be just if you want a moose pad, if you will. It's not a stag, you have a whole different footing, but if you want a permit to hunt a moose.
Okay, that was 15 seconds.
And by the way, 600,000 plus.
So maybe you heard a change while I was out as I throwing some antenna switches, maybe not. Short wave. Got the band switch here. We're on the white band. I'll go to the red band next. Going to this yellow one here. Let's go to the yellow one. We're on the red band. Red band. Pointer doesn't mean much. This appears to be 6 megahertz. Appears to be like 1 to 6 megahertz here. I'm going to pick up anything down here. Road. Now, it's really the next time that we have a chance. Boy, that just doesn't sound good at all, that switch. Yikes. Not much sound. No sound. Switch at the back. So I don't think the band switch is engaging properly at the back. Let's go back there. switch mechanism, of course, is buried back in here. I can't say I've ever really seen a switch break of this sort. These are just wafer switches. I can't really think of a time where I've really had one bust, but they often make bad contacts from dirt. Now this one looks like a really well-built switch. This doesn't look like a cheap switch from what I can see. Let's get in there with the close-up camera because I just can't see enough like this. Now I've got the set switched on, so I gotta be a little bit careful here. Need a little more light. So I'm just curious, first of all, how is it constructed? I'm in my own shade here. Let me just... So I'm going to switch this off because I'm just so nervous about sticking the camera into it. I think we're not looking so much at the switch, we're looking at the, I don't know what we're looking at. What are we looking at? Let me turn this a little bit and we'll watch it. Huh. That sound is terrible. That sound right there. You know, maybe I can figure out which one of these is making that sound. There's three. Scary, man. I think that's, you know, that's the breaking point. I'm rotating it through or something like that. I mean, it could be nothing, right? That sound could be absolutely nothing of any concern. It just feels like things are popping, like they're being put under spring tension, and then they're popping loose. And that's what it feels like to me. It feels terrible. Well, there's nothing leaping out. Looking at it too quickly like this. And I'm trying to get myself familiar with what the switch looks like, so if there's something that's not right, I can spot it. A little better view. Look at that paper capacitor way in the back there. Ay, ay, ay. You know, it looks like. Let me see if I can get close up on this one here. One of these, get a really good look at one of them. Ah, there. That's pretty good. Okay. Lots of really bad sounds. Let me look at the other. I'm looking at the. Let me look at a different face here. Try and look at the face with all the connections on it. What I can do, I can take these out if I need to. So I'm getting the impression that the way the switch works is it's a sandwich with two pieces of bread, and inside the meat is rotating. I think, I've never seen one quite like this. Usually the contacts, the moving contacts, are completely visible on one side of the switch. But I think, see, I think there's a brown phenolic sheet or something like that, and then behind it or under it is a rotating metal sheet, and then on the other side is more phenolic or whatever the material is. Wow, this is what is moving? Like I see the shaft moving, but where's the switch contacts? Is this last one not moving? This isn't the last one. This is right in the middle. There's 1, 2, 3, 4, 5, 6. So when you look at this, so there's a switch wafer here and a wafer switch here, and then these coils are mounted basically on the two wafer switches. So I'm thinking the selector is coming along. It's selecting, you know, first this coil, and then it's selecting this coil at both ends, and each one of these is the same. So there's 6. There's another one in the middle here. Always something, isn't there? Yeah, so this one's got 1, 2, 3 wafer switches. 2 here. Yeah. Okay, let me use my ears. And we'll, in fact, let's try the microphone thing again and see if we can figure out where the clicky, grindy sound is coming from. Okay, so I'm going to get down my microphone here. Okay, let's switch to this mic. I'm just going to listen to each one of these. I think I'm going to have to use the biological units here for this. Oh, I have another approach. I have another approach here with my, depending on my biological units here. Yes, I'm going to listen to a radio with a stethoscope. I'm going to take off my headphones. Another useless attempt there. So, okay, let's just go with the naked biological units here. I'll stick my ear in here. Yeah, my guess, it's coming from here, but I can't really tell. Okay, so that didn't work out. So we can't really figure out where it's coming from. We can't figure out what it is that I'm feeling. We can't figure out why this thing isn't working on the highest shortwave band. We don't even know that it's anything to do with these, that it's not working on the highest shortwave band. We don't know that the last fellow who worked on it didn't dig way back in here, make a mistake, put it all back together, and then that's why it doesn't work. We don't really know anything here about this. We know the radio works, so we know if any signal comes out of the front end, it's going to come out the speaker. So what I mean by that is literally, if there's any signal on the antenna that can get past the first set of coils, we should hear it. Is that so? So I can see when you look at these coils, you can see a distinct difference. A very heavy wire here, much lighter wire, very fine wire covered in wax here. So generally, which way does that work? Who is likely to be the... Also, there's 3 sets of coils for each band. 2 of the coils are doing something similar, but the last one's actually involved in a very different business in the radio, and that's the local oscillator. There's a good chance this is the local oscillator up here. The local oscillator is responsible for the tuning of the radio, which I will get into that a little later, just exactly how this radio and all these radios, super heterodyne radios, actually tune stuff. Once we get a little further into it here. So the problem I'm looking at here, and again, is it really a problem? I don't really know for sure. The higher band on shortwave doesn't appear to have any reception at all. It doesn't appear that way. Maybe it's just really, really weak. Maybe if I ram in a really strong shortwave signal, we will hear something. So let's do that. Let's do that. I had not explored the shortwave bands at all on here until this moment, just in anticipation of there being no problem. But once you get one band working, like let's say the broadcast band working in a radio like this, you've pretty much proved 80% of the radio is working. So there's a good chance once the broadcast band works, they all work, to some degree anyway. So we need a cable here to hook up. Okay, we're going to want to feed this into the antenna. Here, we can do it this way, easy enough. Turn around. Okay, switch this on and see if we can pick anything up with it. Okay, switch on. Volume is just up a little bit. What did I just hear? A click? Did I just hear a click? Okay, I don't know what that was. It seemed to me I heard a click and something changed in my headphones at the same moment. So, what band are we on here? I'll take a look. So we're on the lower shortwave band, which appears to work. Now it's hard for me to know what frequency we're tuned to here with the dial all wonky. Let me look at the capacitor. Estimate how far we're tuned. Well, the capacitor is completely closed, so we're at one end of the band. One end of the band, somewhere around 6. Oh, let's put this up. Now this band works, so somewhere around 6. No, we're at the other end of the band. 1. Get down there. There it is. So I can tell you the radio sensitivity is very, very good on this band. The output from here is very, very low. So this band is already hot, let's put it that way. Now we're going to try the next band up. cruncher. Oh, that was interesting. Okay, well, I think I'm in place, but we don't hear anything. Turn it right up. Wow, it's just nothing. Turn up my other volumes here. Disconnect and reconnect the antenna, see if anything happens. Well, you hear a little bit there. Doesn't prove a lot, you hear a little bit. Okay, we're gonna send in a signal. So we're at the low end of the band, I think. So that would be around 7 megahertz, I think. So I'm reading the scale down here. So that's 5.7. So that makes sense. 5.7 is close to 6. The end of the band is around 6. So it's there. Let me get it back on here. That's a very low signal. So this is now a moderate signal on this shortwave band, and it's picking it up. So why is it so silent? Could be alignment issues. The alignment may be way off. We're at higher frequencies now. Some components are not working the same at the higher frequency. So a defective tube or weak tube could show its weakness at higher frequencies. Much more. So this goes all the way up to what? All the way up to 18 megahertz. Well, let's go up there. Let's go up to 18 megahertz. Yikes. Okay, so we're up around 18 now, 17, 18 up at that end of the band. Let's see if we can pick it up. Right around here. Okay, we'll go up a little stronger. I got everything turned up full here. Full. It's full. Go higher yet? Okay, so now I'm sending a signal to the radio it would seldom encounter from an antenna. It's a really, really strong signal coming here. And it's not hearing it at all. So we're going to go down around the middle. So this band goes from about, actually it goes from 6 to I think 19 again. It's broken at the top there, so we'll put it around. Let's put it around 10. 10's a nice number. So 10 coming out of here. We'll tune this down and see if we come across it. This is putting out a strong signal, so very likely to pick it up. Oh. There it is. Signal. Now, can we make a quick sensitivity study here on just what the problem might be? So it could be, let's see if we can figure out which of these coils it is. Capacitors here. It's only one, like one coil, one capacitor. Either two here. So that to me sounds like the oscillator. It was just tuning the signal. That would make these, particularly this one, Never do this. Don't get in and just start turning stuff. Nothing whatsoever. Okay, stop that. Doing, so I'm going to stop. Well, it's not coming clear doing that. I'm not going to fool around here, because you think you're fixing up one band while you're actually messing up another. So a little bit of conflicting information there. So I'm just going to walk away from that. We'll sort it out when the real time comes to do alignment. So I think it's receiving at high frequency. It seems to be very, very weak. Can't know it's not the alignment. I haven't followed the proper procedures here, so we can't know it's not simply alignment. But that could be the case. With the front dial the way it is, can I align this radio? Or must I wait for the new dial to come, which is on its way? I mean, much of the dial is visible and readable. Well, I could go through, through the process the first time, so to speak, and if I'm not getting it exactly right, that won't really matter, because what I'm after are gross errors in alignment or component problems that become reveals while you're trying to do the alignment. I'm not trying to align it for its final time. So that is adjusting all of these. Maybe that's what's in store tomorrow. Where are we on the clock here? 45 minutes. 45 minutes, eh? And let's just do another heat run test. Check, rather. I can see the paint melting on this. Or liquefying, same thing here. I can see it. Okay, temperature of the first guy. 85. Oh my gosh. 65. 85 degrees, and this is with 100 volt. 100 volts coming in. Oh boy. Well, the what's going on here has not revealed itself yet. That's really something I think maybe that's the thing to pursue next. Really. Pursue it really in depth. Really try to figure out why these guys are heating, or is that normal? Is that the way? I mean, look at the great big things. Look at them sticking out there. I mean, they expected these to get warm. They certainly did. Why don't we do that next? We'll try to pursue these two resistors in depth and try to come up with the actual reason why they're overheating. Or prove they're not. And then what? Yeah, I think that's probably a smart thing to do. Okay, so thanks a lot for watching this. No distortion, we proved that. That bodes well for things like screen voltage, plate voltage, grid bias. All these things are not proven to be correct, but suspicion of problems in those areas way down. Very good. Two hot resistors next.